I'm Colleen Boss, the administrator for the Clear Roads Pooled Fund Study on Winter Maintenance. Clear Roads is pursuing a project to develop a plug-and-play protocol, an approach to integrating electronic devices and sensors on plow trucks. Bill Haley from Force America, who has been one of the leaders on this collaborative project, has joined us. He's going to describe more about the background and the development of the current draft protocol. Bill?
Thank you, Colleen. Yes, I'm Bill Haley from Force America, and I'm really honored to be able to serve on the subcommittee of vendors from the snow and ice vendor community that worked on this project. It really is something special when you can get the major competitors within an industry to join forces and add their ideas and their IP towards an idea like this so that we could standardize something that so far in our industry has not been able to be accomplished. And today, while we're together, we'll review the background of how we got to this point, why there is even a need for a standard for communication between devices inside the cab of a snowplow truck. And we'll talk about the proposed standard that we've come up with, and we will discuss any remaining opportunities we see for future standardization. I wanted to first start off by acknowledging those vendors who did spend their valuable time and resources towards this project. First of all, Jun Zhang from Bosch Rexroth, Jim Talbert from Certified Power, and Rob Henningsgaard from Cirrus Control, my fellow spreader vendors. And Eric Kauger, Brad Howard, Michael Schlag are AVL vendors from their respective companies, and their insight was especially valuable when it came to the AVL devices and the GPS devices. Why did we get here? Why is there a need for standardization? The real challenge in any industry is that there's a job to be done. There's work to be done, a problem to be solved. And that job has a certain shape. It has requirements that define what's required. That's called the need. And to meet that need, vendors come together and they create a tool. It's usually shaped exactly to fit that need early on. And the world is happy. Over time, however, without a guide or a written specification about how things are going to develop, the need will evolve, new technologies come on board, and the shape of the need changes. And thus, the tools are driven to change. Vendors, through their creativity and through their own foresight, will add features here or there that they foresee the market will need at some point. But ultimately, the tools do the work that the job required. When there are multiple vendors and multiple parties involved without a specification, everyone's going to develop a tool that will handle the job, but without, in the vacuum of competition, very few pieces of information are exchanged. Thus, the solutions look totally different behind the scenes. So one version is going to communicate totally differently than another, yet they accomplish the same task. How does that look when it's finally implemented in the fleet? Well, fleet supervisors do try hard to standardize their fleets for easy maintenance, easy training of new supervisors and mechanics as they come on board. And over time, they establish a fleet that's pretty consistent. And if they've used one vendor for the spreader control, for instance, and later on, new technology becomes available, such as AVL devices, they may find a perfect fit AVL device that accomplishes everything they were looking to do and fits and is compatible with the equipment on the trucks. And they can standardize that across their whole fleet. Other fleets are not quite so standard, especially larger fleets where over several bid cycles and over several different bid awards, different competitors will have equipment on the trucks. And the solution that works so nicely for one spreader control and AVL combination does not work automatically out of the box with the other equipment. So we have a problem. To date, that has been resolved through some heavy lifting by the AVL vendors. They will adapt their technology, write some firmware so that they can take data streams from the existing spreader controls and any sensors they may have to connect directly to, and they'll adapt that down so that there's a common format for all the data coming from the trucks. And that is workable. However, the truth is that given the number of AVL vendors and the number of spreader control vendors, the complexity escalates quickly in that there's a challenge in communicating between every single one of these combinations. And it would be very difficult to expect that every vendor would be able to support everybody else's protocol. So this is ripe for a standard. And ClearRoads knew this. They went out and published some RFPs. There was some research done, and the industry was surveyed for examples of existing standards we might be able to apply. And exhaustive studies and research was done. And at the end of it, one of the reports, the most recent one, recommended the use of J1939 vehicle bus. What that is it's a network communication protocol between devices on a mobile device, on a truck, where the engine can communicate with things like anti-lock braking systems and so on. And this is a really good idea. There are benefits if we could use that CAN bus on the vehicle itself to also integrate sensors for the snow and ice equipment, the spreader control, display data, and all of that. The vision, I think, when that document was published, was that the spreader devices could hang off of the bus according to this illustration, where sensors and all of the equipment could just be connected simply to a CAN bus along with the engine diagnostic equipment and all of that. However, the reality is that in the snow and ice market, there is a central controller, and the spreader vendor community acknowledged that while there may be CAN buses, proprietary CAN buses for the spreader control equipment, it would be very difficult for all that equipment to reside on the vehicle bus because of the amount of data and the need for very rapid response to sensor input and controlling functions like wings and hoists and plow blades. The timing just wasn't as time critical as what the spreader controller would require for good control. So it wasn't quite a perfect fit. And we looked into the future, and we can see that video on board vehicles is going to become an important thing. And over time, it will probably standardize in most vehicles. When you add video data, especially streaming video, that is an incredible amount of information to send across, especially for sending it back to the headquarters. If we then are also sending weather backwards, back to the vehicle, that bus is going to get pretty congested, and we could face some real issues there. So we don't believe that the J1939 bus was the correct solution, at least long term. And we also acknowledge that we don't know how technology will evolve over time. I mean, what is the shape of that need in 5 years, 10 years from now? And can we come up with something that's going to be flexible enough that we can adapt to what we can't see in the future? We know this. Rigid lists of data fields and technologies we know today are soon going to be obsolete. As soon as we publish it, someone will release a new sensor or new technology we never thought of. New features are going to be needed, and we just won't know what they are. So the solution has to be something we can shape and apply and fit to any circumstance that we know today and that we can't foresee coming. And the best analogy we could come up with was with some of us having children at home is a toy doll, something that we could shape and the kids play with and can pretty much take any form you want. So if you can just bear the analogy for a moment, regardless of what shape that AVL device is in terms of features and protocols that it already has, And whatever shape that spreader device is, given its sensors and its capabilities, processor power, if we could tack on something universal to what's already there that's sticky and shapeable, and we can stick it together with that same idea on an AVL device, well then we could fit together any combination of devices from any vendor, so long as they have implemented that sticky part, which is called the universal protocol that we're talking about today. What does this mean for us? It basically means that we're going to define a spreader piece of clay and an AVL piece of clay, but between the two of them, the common parts are specifying a data format, specifying the protocol itself, specifying baud rate, which is how fast the data can communicate, how sensors are going to be negotiated between the spreader device and the AVL device. For instance, if there is a row temperature sensor connected to the unit, it may be supported by both the AVL device hardware and the spreader device. And depending on where it's connected, we wanted the protocol and the process to define how the data would be plugged into the data stream coming off of the truck. It needs to be negotiated between the devices so that the data requested by the fleet management is whole. And again, future flexibility. The solution that we're proposing in the specification document looks like this. On power up, the vehicle is going to check memory and make sure that between the spreader control and the AVL device that there is no old data on that truck. You know, perhaps the vehicle came into the yard and communications were down for some reason. We want to make sure that before any changes happen on that vehicle, immediately on power up, we move that data off and start with a clean slate. Once that's done, the vehicle is going to accept a new configuration from the back-end database or from the server. Supervisors are going to be able to, through this protocol and through some sort of web interface, set the pieces of data that they want to collect from each vehicle and how often they want to collect it and so on. That information, that setup of how the fleet supervisors want to receive that data is going to be pushed out to the trucks. And the truck is going to take that information then and make whatever necessary changes. How that's done is ClearRoads is going to host a living, breathing document, a definitions file called the Data Parameter Library. And the web interface that the fleet supervisors are going to have access to, provided by their AVL vendor, is going to look out to this file at a regular basis and get an updated list of definitions. You know, what kind of data can I get as a supervisor from my trucks? And they're going to select what they want, and they're going to then send that off to the truck. By having this as a controlled document, it standardizes the names of the fields so that all vendors know what to call it and there's compatibility. And it defines what the format is of that information. You know, is it an ASCII text information? Is it numerical? Is it a percentage? Is it pounds? Is it degrees? All of that is defined within this document. And since ClearRoads controls it, we can make sure that nothing is added or taken away without taking into account the entire standard and everyone who would be affected by it. That vehicle configuration message that will be sent to the trucks after startup is going to, again, set the sequence of data fields that come off the truck and what those fields will be called. And that's really important because by defining that on every power-up, we can say that on the first day, we'll request time and then date and then pounds of salt, dry salts that are spread, row temperature, and so on. And then on day 2, we could take and shuffle that up and say, look, we only want 2 fields. And all we want to see is we want pounds first, and then we want time second. And through that configuration message, we can change that on the fly, but we'll never lose data, and it will always plug in easily to the back end because of the way it's defined through this configuration message. It should provide the flexibility we've been looking for, and we're looking forward to that in implementation. The vehicle configuration message really is just saying to the vehicle, look, the fundamental definition of what you're doing is you are a spreader, or you are a plow truck. You are going to be giving me X fields in this sequence, and you take all the little pieces of information, consider that like little itty bitty pieces of dough, and you can slam that all together into one big data chunk. Again, very flexible and can be shaped per need. So what that vehicle configuration message really does is it acts like an extruder shape. So again, this analogy of having this toy dough that you can press into any shape, the configuration message basically sets how that the shape of that data going forward, so that this flexible data we've got on the truck can now be squeezed through this lens or this extruded die to the shape that the supervisors need. Once the configuration has taken shape and has been implemented, data will begin coming from the vehicle to the servers, and that process will continue throughout the vehicle's route. And you'll note that there is not just one directional arrow, but there is actually both an orange arrow in and a blue arrow out. That's to indicate that there's handshaking, two-way communication between AVL devices and spreader controls, as well as from the truck itself back to the servers. That guarantees that there's proper communication of data and that nothing is lost. So no data is deleted until there's an acknowledgement that the data was sent and received successfully. And that's going to be key because we don't want route data, material usage data to be dropped or lost at any point in the cycle. So this is a really big piece of the quality of this protocol. Just a few notes then. The spec we feel is fairly complete, though we will undoubtedly find some things through implementation in the next few years of use that we'll want to add. But what we're committing to as a group is that the data parameter library, for instance, we can add new data fields to that document, but we can't edit fields and information that have been entered. That would create too much of a moving target and really create some backwards compatibility issues for us in the future. So we want to avoid that. So that will be a fairly rigid process for adding items to that DPL. And spec changes to this protocol should be rare, if any are made at all. So again, we may append to this document as we find a need, but we really need to be careful about not changing what's already written and what has already been implemented in the field. And at all stages, the vendors are going to commit themselves to making the software flexible, tolerant of future changes, so that we don't end up with mothballed equipment or a spec that won't live and breathe and grow with us. How we're going to test whether or not our products have successfully implemented this protocol. The vendors discussed this, and really one of the best ideas that came out was, rather than having a plug fest, which is where everybody shows up in a conference room and plugs their equipment together and shows, hey, look, we work together. We wanted it to be a little bit more spec driven, and we are going to work with ClearRoads to have a scope document created where someone will create an application that will be a perfect software model. We call it the test bed for terminology's sake. And the test bed software will exercise our equipment and behave as if it was either an AVL device or a spreader control. If I'm testing a spreader control, I can connect to this test bed, and it should fully test that my spreader control equipment has passed functional test and will meet the protocols. That way, vendors can come, they can use that test bed, they can qualify their equipment, and after that they can be registered with ClearRoads that their equipment at a certain firmware version has passed test. And that will give fleet supervisors a real tool in knowing that when they go to bid, that a certain vendor and certain pieces of equipment are going to be compatible and that they do meet ClearRoad spec. And that'll be a huge relief for those folks who need to make those decisions. So we're going to manage that process. You'll see a lot more information about that coming up. We've talked a lot up to this point about communication on the vehicle. There's still one half of the solution that we'd like to do more with standardizing, which is the back end, the server side. And in previous studies, that was acknowledged as a real opportunity in this discussion of standardization, that the database could use standardization. Really what that means is that rather than having each state entity and each municipality develop and engineer their own formats and their own databases for their information systems, that we could standardize that, and then AVL vendors specifically, when they send their data back to the customer, back to the fleets, that it could be done in a standard way so that AVL vendors didn't have to have so many custom solutions per municipality, rather, and likewise, that municipalities weren't left to their own to develop these systems, but rather we could pool our knowledge and come up with a solution that was the same over and over again, repeatability. Known data types and ranges allow for standard backend data structures, so we wanted to cover that as much as possible. We would like to predefine data access methods like .NET Web Services. We believe that that's really has some power for this industry. Stored procedures and file dumps. And then state system data structures can be pre-configured for the known data structure. And data from legacy equipment can be modified to match ClearRoad's format at the AVL modem level. Basically, AVL vendors could even figure out a way to communicate with legacy spreader controls that don't support the ClearRoad standard and take that information, package it up, wrap it up in a way that would be compatible with the ClearRoad's protocol going back to the database. So that would be powerful. And then standardized reporting. So the complete solution really is three pieces. It's standardizing how spreaders talk to AVL devices and backwards from there, and then how the AVL device is going to communicate location and data back to the database. And if we could standardize all of those pieces, we would have a complete solution. I want to thank you for your time and for looking through the spec document. If you have not looked through that document yet, you're encouraged to do so. We're releasing this document for public review and comment, and that document will be posted on the ClearRoads website through February 28th, and we really need your feedback. Please review this with your IT professionals and anyone involved in your internal data structures. Discuss what we've shared on this informational PowerPoint presentation as well as what's in the document, and let us know if you have any questions. You can funnel all questions and input feedback to Colleen Bass at CTC and Associates. And again, get that information back to us by February 28th. And I want to conclude the presentation at this time and just thank everyone again and acknowledge how big of an accomplishment this is for our small industry to come up with some standard that will allow all of us to still exercise our competitive creativity while providing a real value to the community with this standard. I hope you've gained a lot of knowledge through this presentation, and it's been a real privilege to serve on this committee. So thank you, Colleen.
Thanks, Bill. Nice job. We really appreciate your reviewing this information with everybody, and I'd just like to second what Bill said. We really appreciate any comments that you can share, and you can send them to me at colleen.boss@ctcassociates.com. Thank you.